Number 18, 3y equals 4x plus 17 and negative 3y equals 9x minus 23. The solution to the given system of equations is x and y. What is the value of 39x? Notice they are not asking you what y is. We don't need to know what y is. It doesn't matter. The only thing that's important with that first sentence there is that they're telling us there is a solution. It doesn't matter that the solution is saying to the given system of equations is x and y. Like, do I need to know that? Do I need to know what y is? No, you don't. You just need to know there is a solution. Because in linear equations, there's only three options. You can have two lines that cross. You can have two lines that are parallel. Or you can have two lines that are identical. So when they cross, we have a single solution. When they are parallel, we have no solutions. And when they are on top of each other, we have infinite solutions. So the fact that there is a single solution tells us the lines cross. There's one solution. Okay, good. Now you can put this into your calculator. You type all this in and you'd see where they cross. That would give you the coordinates of x and y. And then you can take that x value, multiply it by 39 and get your answer. Nothing wrong with that. My preferred method, and when I look at it, this would be faster for me. I look at these two and I go, okay, so a system of equations, you can solve it by graphing, substitution, elimination. Those are your three methods here. Right off the bat, these two, that 3y and negative 3y, they are going to cancel out. So I'm going to do elimination. And I also am doing this because they're not asking for x. They're asking for 39x. And any time that they ask for a weird variation, like, here's the solution, x and y. What is what is 6x plus 2 equal to? What is 7x minus 15 equal to? It always gets me thinking, and 9 times out of 10 this is the case, that if I do something like substitution or elimination with these equations, I'm going to get an answer, or like somewhere along the way, I will get something that's close enough to 39x that I can kind of jump ahead a few steps. We'll see if that happens here. All right, I am going to add these together. So that is how we eliminate. These are going to cancel out. So when we add them together, 3y and negative 3y is 0. There we go. 4x and 9x is 13x. And 17 and negative 23 is negative 6. All right. And here I see, I'm like, wait a minute. I see what's happening. Because if I solve this, spoiler alert, I'm going to get a fraction for x. And I'm not a huge fan of fractions. I don't know about you. Most people are not a huge fan of fractions. So if I can avoid the fractions and having to deal with that and converting, I'm all for it. And here's what I see. What stands out to me is this 13x. 39x is 13x times 3. So if I quickly solve for 13x by adding 6 to both sides, I get that 13x is equal to 6. So now to find out what 39x is, I don't have to solve for x and then multiply by 39. So I would get 6/13 and then have to multiply by 39. I don't have to do that. I can just go, hey, I want this to be 39x equals something. So if I multiply both sides by 3, ooh, missed that, missed my parentheses there, then I will get 6 times 3 or 18 is equal to 13x times 3 or 39x. So for me, I'm good at elimination. I know that about myself, that's a skill that I can do that quickly. For me, this will be faster than graphing it. If graphing is faster for you, by all means, graph it. The one sort of thing that you're going to recognize there, though, is, because x is 6/13, if we had solved for x in this stage right here, we would have got x is 6/13. When you go to look at the graph of, where they intersect, whatever those lines look like, you're going to get this decimal for x. 6/13 is going to be an ongoing decimal. It's not going to stop. And so you're going to get a number here that will be a decimal. And when you multiply it by 39, you're not going to get one of these exactly. It'll be close, but it won't be that exactly if you use a rounded decimal for this XY. And that may cause a moment of confusion and go like, wait, did I get it wrong? No, it's just because you're rounding, that sort of thing. When you do it this way, you find out precisely that it is 18. So that's my only sort of cautionary statement on this one, is when you do it by graphing, you're going to get a fraction, or you're not going to get this fraction of 6/13. You're going to get a decimal presented to you. On most calculators, they will present it as a decimal. And then when you multiply by 39, you're not going to get exactly one of these. Don't let that, confuse you or get you away from the wrong answer. Going like, did I do something wrong? No, you didn't. D18 is your answer. And they're trying to push. How do I say that? Push? I don't know why I said it that way. They're trying to push you to do elimination because you reach this little halfway point where it can very quickly become 39x and you don't have those decimals involved. Yeah, that's how they're trying to catch you on this, trying to force you to do elimination. But it's ultimately your decision. And so you get D as your answer. Hey guys, the full insanely comprehensive SAT math prep course I've been promising for so long is live right now at mathwithalyssa.com. And of course, you can also still get the free 10 video course on SAT tips and tricks at mathwithalyssa.com as well. You also can now book one-on-one tutoring sessions with me. Links to how you can do that are in the description and the pinned comment below. And as always, if the video you just watched was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.